Hello class, today we're going over notes on 3.3 in Algebra 2, graphing systems of linear inequalities. So first, the graph of a system of linear inequalities is the graph of two linear inequalities on the same coordinate plane The solution for the system is where the shading overlaps. So there's going to be more than one ordered pair that is a solution. Any ordered pair that is in the shaded region is a solution to the system. So for the first step, we want to graph the inequalities, and then we're going to shade. The region where the shading overlaps, again, is our solution. So I'm going to start by graphing the first inequality, 3x plus 2, this one here. I'm going to do it in blue. Having colors for these sometimes helps. It may be helpful to use colored pencil when you do your assignment. For this graph, I go up 2 and put a dot for the y-intercept. My slope is 3, so I count up 3, right 1, up 3, right 1. I also go down 3, back 1, down 3, back 1. Now, since it's less than or equal to, this is a solid line. Now we do shade. I would shade one graph at a time, one line. So for this one, I can use that point 0, 0 as a test point since my line doesn't go through it. So to test 0, 0, I'll substitute 0 in for x and y. So I get 0 is less than or equal to 3 times 0 plus 2. 0 is less than or equal to 3 times 0 is 0 plus 2. So I get 0 is less than or equal to 2. This is a true statement, which means that I am going to shade on the side of that test point. Since that test point created a true statement, all of these points on that side of the line will also work. I'm going to go ahead and color this in. And then once you do that, you can start on the next line. So for the next line, I'm going to start by highlighting that area. So this line is going to be a reddish color. Y is greater than negative x plus 4. This will be a dashed line because it's not or equal to. My y-intercept is at 4. My slope is negative 1, so I go down 1, right 1. I can also go up and back. Now, since this is a dashed line, we'll do it like this, making sure to make obvious that it is a dashed line. Again, we need to test a point. I'm going to use 0, 0 again because it's the easiest of all the points and it is not on our line. When I test 0, 0, I'll replace x and y in my equation with 0. So I get 0 is greater than negative 0 plus 4. 0 is greater than 0 plus 4. So I get 0 is greater than 4. This is false. 0 is not greater than 4, which means instead of shading on this side of the red line, I will shade on the other side of the red line. So I'm shading on this side, the opposite side. Notice when I shade in this region, the part that overlaps with the shaded region of the blue line changes color. So this area that changed color where we overlapped, that's where all of our solutions are at. Okay, so our solution is in that region, right in this region here. Okay. And that's it. We're done. For example 2, we're going to graph the system of inequalities again. For this first inequality, I'm going to go ahead and just use intercepts. So 4x plus 2 times 0 equals 8. So I get 4x plus 0 equals 8. When I solve for x, I get 2. So that means my x-intercept is 2, 0. For my y-intercept, I do 4 times 0 plus 2y equals 8. 4 times 0 is 0, so I have 2y equals 8. Divide by 2. Y is equal to 4, so my y-intercept is 0, 4. Since it's greater than or equal to, this is going to be a solid line. So I'm going to plot the x and y-intercept, 2, 0, 0, 4. And then I can draw a solid line through, connecting those. We do, again, have to test a point. I am going to use 0, 0. Remember, when you test, you replace x and y with the values in your test point. So I'll have 4 times 0 plus 2 times 0. And I'm going to see if that's greater than or equal to 8. Well, 4 times 0 is 0. 2 times 0 is 0. I get 0 is greater than or equal to 8. This is not true. So instead of shading on this bottom portion where my test point was at, I shade on the opposite side of my line. I'm going to shade on the upper portion. Now I'm going to follow the same process for the next line. The next line is dash. I don't have to rearrange it. My y-intercept is negative 3. My slope is negative 2. I'm going to go both directions when I plot this. And this is a dashed line. I can still use 0, 0 as my test point. If I use 0, 0 and substitute, I get 0 is less than negative 2 times 0 minus 3. 0 is less than 0 minus 3. 0 is less than negative 3. This is not true. So instead of shading on the right-hand side of my line, I shade on that bottom-hand side. Notice when I do this, we are not going to have an area that overlaps. Okay, there is no shaded region that overlaps, which means that this system has no solution. So you would want to write no solution. And that's it for that problem. In example 3, we're going to graph the system. We have y is less than 2 and y is greater than or equal to the absolute value of x minus 1. These are different lines than we did in the last couple examples. For this first one, y is less than 2. So at 2 on the y-axis, we would make a horizontal line if this was y equals 2. Since it's less than and not equal to, it's a dashed line. So we're going to make a horizontal dashed line at 2 on the y-axis. And then we're going to test 0, 0. It's okay that there's no x in this equation. We will replace y and not worry about x. Notice when we do that, we get 0 is less than 2. That is a true statement, which means we will shade towards the point 0, 0. So we're going to shade in this lower region. And we're going all the way down. Okay, next, we want to graph y is greater than or equal to the absolute value of x minus 1. So this is going to be solid, and it's a V shape. So our vertex is at 1, 0, and our pattern is just 1, 1, 1, 1, and that I know that because of the absolute value symbols. So I go to 1, 0, put a dot. My pattern's 1, 1, 1, 1, so I go up 1, right 1. I continue that pattern. I can also go up 1, left 1. This is a solid line, so solid on both ends with arrows. And then we need to test a point. We can still test 0, 0 for this one. When I do that, I get 0 is greater than or equal to the absolute value of 0 minus 1. 0 is greater than or equal to the absolute value of negative 1. Well, the absolute value of negative 1 is just 1. 0 is not bigger than 1. This is false. So instead of shading on the side of the V that has 0, 0, we will shade on the inside. Now when we do this, notice the portion that gets darker inside that little triangle area. That is our solution to this system. So the solution is only where the shading overlaps. So the overlap portion of shading is our solution. We're done with that problem. Okay, we have one more problem here. We have 4 lines in this one. 2 vertical, and then we got some regular lines that are in direct variation form. So for these first 2, x is greater than or equal to 10. Well, I go to 10 on the x-axis. This is going to be a solid line, and it's vertical. When I shade for this line, we have to think about the fact if we test 0, 0 is 0 greater than or equal to 10? No. So we would not shade to the left, we'd be shading to the right. So I'd be shading on this side. Now something I should have thought of when I was doing this is notice the next one says x is less than 70. I should probably go by different values on my x-axis to fit this all in. I'm going to go by tens, and I'm going to redo this. So I'm going to erase this all. I'm going to move my line. I'm going to do the shading to the right. Okay, let's go ahead and do that x is less than or equal to 70 now. So at 70, I have a solid line again because it's less than or equal to. And if you think about this one, if you test 0, 0, you get 0 is less than or equal to 70, which is true. So I'm shading to the left. So I'm shading the opposite direction. I don't really like the way that color looks. So we have a little bit of overlapping so far, but keep in mind we have 2 more lines we need to graph. Okay. Now for this next one, it's a solid line. We start at 0, 0, and our slope is 8 over 7. So 0, 0. So 8 over 7 is really small amounts. I could potentially, that's the same as doing 80 over 70 if you reduce it. So I could go up 10, 20, 30, 40, 50, 60, 70, 80. Go right 70. Same idea, right? Okay. Could go backwards too. And this is a solid line. We cannot use the test point 0, 0 because we go through it for this problem. So instead, let's do 30, 0. Okay. So I just picked some other random point that's not in any line. So I get 0 is less than or equal to 8 over 7 times 30. 0 is less than or equal to 240 divided by 7. So it goes in 34 times. So it's about 34 and 2/7. 0 is less than that. So we would shade on that side of the line. So I'm shading on the bottom portion. Hold on here. Notice how once again the shading is changing color. The more colors we add, the more it changes, the more overlap we have. Okay. All right. Now, let's do our last problem. For this one, it starts at 0, 0 again, except for this time it's 2/7, so 2 on t over 70. I'm going to use black. It's getting a little mushy here. And this is a solid line again. Again, we can't use 0, 0 to test it, but we could use that 30, 0 again. So I get 0 is greater than or equal to 2/7 times 30, greater than or equal to 60 over 7. Well, 60 divided by 7 is going to be bigger than 0, right? So we'd shade on that side again. Now I'm just going to use the black marker this time. And then when we do this, the final part that's overlapped the most with all the colors, so the portion that is overlapped completely with all 4, is this section right in here. Okay, I'm going to make it a little darker so you can see it a little better. It's this entire portion here. There we go. So that would be your solution, is this strip where they all overlap. And that's all you would have to do, is make sure that that shows the darkest region of your shading, and you're done. That's it for notes today as well. If you have any questions, be sure to contact your teacher.